Hi, my name is Brandon Howell and I cover technical marketing for Intersil's digital power products. In this video, I'm going to introduce PowerNavigator and its integration with our latest family of digital power multi-phase controllers. PowerNavigator is Intersil's GUI for use with all of our digital power controllers. It's used to configure, set up, read back real-time telemetry, and also debug systems all in real time. For today's demonstration, we'll be using the ISL 68137 7-phase digital multi-phase controller. Here I've got the demo board. It's powered by a 12-volt and 5-volt bench supply, and I have a PM bus and AVS bus connector that go to my PC, and those interface with our PowerNavigator software. So looking at PowerNavigator, the first thing you'll see is the power map. The power map gives a system-level view of all of the products that are connected to the GUI. Here I show the ISL 68137. It's a dual output device, so I have two blocks on the power map. One block has all 7 phases assigned to it. This is highlighted by the 7 green dots inside that rail block. On the right-hand side, I have our monitor view. Monitor view shows back the output voltage, the input voltage, the load current, all the telemetry from the device in real time. If I double-click on the rail block, I bring up our Rail Inspector design tool. Rail Inspector is how we configure the device. It has the rail name, its status, and on the left-hand side is a menu. As I walk through the menu, I'm able to fully configure all of the features inside this product. The first screen we'll look at is called Phase Configuration. Phase Configuration allows me to assign each one of the phases to one of the 2 control loops inside the device. On this particular board, I have 7 phases assigned to loop 1. It also allows us to enable auto phase dropping for improved efficiency. When auto phase dropping is enabled, as the load current changes, we automatically add or take away phases. The thresholds for auto phase drop are all configured digitally and done so on this screen. The next page is a general configuration page. This does the output voltage settings, including the fault limits, as well as the switching frequency. The powertrain page is used to set up the powertrain for this device. You input the MOSFET properties, the inductor that you're using, the output capacitance, and its properties. We also set up the current sense gain. This demo board uses Intersil's Smart Power Stage, which automatically provides current sense information back to the controller, making current sense very easy to set up. The next page is the transient setup page. The transient setup page is where you configure the digital control loop inside this device. It's used to set up the control loop gains, AC current feedback, and then additional things like pulse advance and load line settling to improve the load transient response. If you're using a load line, the droop impedance is set in the R-droop box. The next screen is diode braking. Diode braking is used to improve the transient response by turning off the low side MOSFET during a load release. This can reduce the overshoot of the output voltage, improving the overall response of the controller. Ramp time is used to set the on delays, the off delays, as well as the rise and fall times of the controller. The final screen here in the general loop configuration is the temperature sense setup. This enables an external diode, or the T-mon output from the Smart Power Stage, where the controller can measure the real-time temperature of the Smart Power Stage. Moving on to the fault section, all the faults in this device are configured digitally. So the fault responses, the fault thresholds, all are configured with this graphical user interface, making the responses and the setup thresholds very easy to set. We have voltage, we have current, and we have temperature faults. They're all configured with the GUI. The final thing is a black box. Black box is used to automatically trigger black box capture in the case of a fault. When enabled, if a fault happens, the controller captures all the telemetry information and saves that to the device. This can be used for debug later on and as a way to tell exactly why a controller shut down. Once the device is fully configured, you have the memory configuration page. Inside the device, there are 8 different configuration IDs that allow you to save up to 8 unique settings inside these controllers. Once you're done configuring, you would simply hit Save, and that would save that setting to one of these 8 slots inside the device's non-volatile memory. The Rail Inspector tool also has advanced features like AVS bus. AVS bus is a fast point-to-point communication with up to 50 megahertz speeds. This allows the part to communicate with ASICs that support AVS bus interfaces in a very fast manner. With PowerNavigator, you can very quickly evaluate and demonstrate AVS bus and see the dynamic response behavior of the controller with an oscilloscope. The final page here is the telemetry page. Telemetry allows you to plot real-time telemetry of the device. This includes input voltage, output voltage, current, etc., all plotted in real time, as we've shown here. So I hope this video was helpful in explaining how Intersil's PowerNavigator software interfaces with our new full digital multi-phase controllers. For more information, please visit our website at www.intersil.com.